下面是 Part 3 Gravity. Which of the following diagrams of two planets would represent the largest gravitational force between the masses? OK, 同样，首先需要记在心里的就是说它的表达形式 gravitational force m1 m2 over r squared. And this time, this question is easily done by make comparisons between between choices. First one and the second one, you find that okay, the second one, this guy should be greater than first one. So we leave this one here and compared with the third one. Okay. Compared with the third one, the distance is 2r, and which is larger? Okay, 2m over 4r squared, which is the same as the first one. So the second one should be larger than this and larger than this. Okay, we still keep the second one. And for all of the following, should be smaller than second one. So the right answer should be the second one. Next, a satellite is in orbit around the Earth. Consider following quantity distance from the center of the Earth. Okay, mass of the Earth, mass of the satellite, gravitational acceleration depends on which of those above. Okay, of course depends on this because acceleration is determined by force over mass. So mass of the satellite, of course, and it depends on mass of the Earth. So we write it out. G m capital M small m over r squared over m, which is equal to G capital M over r squared. So it is easily seen that it depends on acceleration depends on mass of the Earth and distance from the Earth, which is r. So it has nothing to do with mass of the satellite itself, which is small m. So it depends only on 1 and 2. Okay. Then the third question. A satellite orbits the Earth. It passes points A and B. Satellite A is traveling faster at point B than at point A. Consider the following statements. Okay, if it is known that it is faster at A. Okay, we make a comparison A and B. We compare the kinetic energy and the potential energy. Since A has a larger kinetic energy and a smaller kinetic energy for B, and since the total energy should be conserved, if you have a larger kinetic energy, you should have a smaller potential energy. Okay, again this time a larger potential energy for B. Okay, greater in speed, there should be faster at B. I'm sorry. If it's faster at B, so we can change the two parts. It is faster at B. Okay, which means B should have a greater velocity. The speed is greater because you have a larger kinetic energy. You must have a larger speed, and kinetic energy is greater at B than A, which is also correct. So the gravitational force is greater at B than A, which is false. The angular momentum is greater at B than A, which is also false, as we know that, as I emphasized, that the angular momentum is conserved during the orbit motion. It is conserved because there is no torque. So the angular momentum is always conserved during the whole journey of the orbital motion. So 1, 2, 3. As the planet orbits the sun, which of the following must remain constant? Okay. Velocity is not necessarily a constant because it can be an elliptical orbit rather than a circular orbit. So it can experience change in velocity because of change of kinetic energy. So velocity is not necessarily constant. Gravitational force, of course, is not necessarily constant because it can have different R. It has different R, different distance from the sun. Okay. Radius of orbit. Okay. Of course, not necessarily a constant. And angular momentum, which must be a constant because this force, the gravitational force, exerts no torque on the planet. So if there is no torque, the angular momentum is always conserved. The product of mass and velocity. Okay, mass is a constant. Velocity changes, so it can't be a constant. So the right answer should be 4. Okay, that's it.